Hello, dear students. Ethylene chloride on treatment with aqueous KOH gives. Ethylene chloride means it's a geminal dihalide. So, two carbons related geminal dihalides I have taken. So, it is reacting with aqueous KOH. Substitution takes place. Two chlorines are substituted by OH. So, on the same carbon atom, two OH groups are present. H2O will be eliminated in this manner. So, respective aldehyde will be formed. So, option 1 is the correct answer. Write the product of the following reaction. So some compound is given, it is reacting with hydrogen NH2 and NH2, then what is the product? So if you see the reaction now, so this compound whenever it is reacting with NH2 and NH2, so with this C double bond O, nucleophilic addition reaction takes place. So this from here O and from here H2 is going out as a H2O, then this C double bond N NH2 is forming here. So same compound just by changing the positions of methyl and NNH2 I have written, but both are the same compounds here. So here from here NH2 is going out, here minus will come, here plus will come. So whenever this bond is breaking, here minus and plus. So plus and minus new bond will be formed here. So this is the final product. Option 1 is the correct answer. X is the product of crossed aldol condensation between benzaldehyde and acetone. What is its structure? So we need to do the cross aldol condensation by taking the benzaldehyde and acetone. See benzaldehyde and acetone. So in cross aldol condensation, where alpha hydrogens are present out of these two, acetone is having alpha hydrogen. So from the benzaldehyde C double bond O group we are using. And from here to alpha hydrogens if we remove, between this carbon and this carbon double bond will be formed. This is the final product. So option 1 is the correct answer. So on benzene ring, so CHO and OCH3 both are present para to each other. It is reacting with formaldehyde in presence of KOH and followed by heating. So products A and B will be formed. What are A and B? That is the question. So here if we see these two clearly, so it is showing Canezerose reaction, right? Because both the aldehyde groups are present here without any alpha hydrogens, and in presence of alkali, reaction is taking place. So it undergoes Canezerose reaction. According to Canezerose reaction, the aldehyde group which is having less steric endurance that undergoes oxidation, and which is having more steric endurance that undergoes reduction. If HCHO undergoes oxidation and CHO group is reduced to CH2OH group. So option 1 is the correct answer. This is the final product. The acid D obtained through the following sequence reactions is as follows. So C2H5Br reacts with alcoholic OH. Elimination takes place. So from one carbon atom hydrogen, from another carbon atom bromine is going outside. So double bond will form between the two carbons. Now it is reacting with the bromine in CCl4 medium. So it is the test for unsaturation. So one pi bond will break here. Two bromines will be attached one on either carbon atoms like this. So now it is reacting with excess of KCl. Two bromines are substituted by Cn. Right? It is undergoes acidification and hydrolysis. Then cyanide on hydrolysis, on acidic hydrolysis, it will convert into respective acid groups. So COOH, COH. So succinic acid. This name is succinic acid. So first option is the correct answer. Now some compound is given. It is reacting with KOH, H2 and delta. Product is C7H10O. So which of the following is the product? Now, so this compound KOH is given, no? So that's what it undergoes. So intramolecular aldol condensation, because to the given compound, if we give numbering from the CHO group 1, 2, 3, 4, 5. So fifth carbon and third carbon are alpha hydrogens with respect to the C double bond O. So fifth carbon alpha hydrogens I am using. So if we apply aldol condensation from fifth carbon to hydrogens, we are removing, and from here double bond we are removing. So this carbon and this carbon is linked with double bond. So that is called crossed aldol condensation. So 5-member respective 5-member ring will be formed. Phenyl magnesium bromide reacting with the tertiary butyl alcohol gives. See here, phenyl magnesium bromide, it is reacting with the tertiary alcohol. So what happens here? So in Grignard reagent, a carbon will get negative, magnesium will get positive, right? Bond will break in this manner towards the carbon atom. And here, towards the oxygen bond will break, acidic hydrogen will go outside. So this H plus will be attached to this carbon minus on benzene ring. So benzene is the final product. So first option, second option, sorry, B is the correct answer, second option. Which of the following is the correct option? Means the reactant is given, product is given. So if we use which of the following sequence, we can get the product from the given reactant. So option 1, if we see, so we are trying with by taking option 1 first. So reactant I have taken here. So it is undergoes ozonolysis. If we do ozonolysis, this bond should be break and two sides we should write double bond O and double bond O, shortcut for the ozonolysis, so reductive ozonolysis. Then it undergoes reacting with base. It is given here, no? So which means that it's a aldol condensation, right? Because on the first carbon atom C double bond O is there, and on the fifth carbon atom alpha hydrogens are present. So from here double bond O we need to remove. From here two hydrogen atoms we need to remove. Right? So between the fifth carbon and first carbon double bond will form. So this is the final answer. So it is a intramolecular aldol condensation. The product X of the following sequence of reactions is this reactant is given. Reactant is reacts with oxidative ozonolysis. O3H2O2 means it undergoes oxidative ozonolysis. So first we are applying the oxidative ozonolysis. So if we do oxidative ozonolysis, so what happens here? This bond will break. Then here double bond O and here double bond O should come. Right? So this is the product and it undergoes reacting with OH minus and heating followed by heating. So it undergoes intramolecular aldol again. So assume it is the first carbon. So from here C double bond O we are removing. And from the seventh carbon atom alpha hydrogens, if we take two alpha hydrogens from here, so between the seventh and first double bond will form here. Right? This is the final product. So it is also having intramolecular aldol condensation only. Which of the following will be product of the following reaction? So these two are reacting together. So what happens here? So first carbon having OH group, no? Second, last carbon also having OH group, no? So in these two, see here. So this compound I have written in this manner. So assume it is a first carbon. This is the first carbon. And this is the last carbon having OH group, no? It is the last carbon. Just for our convenience, I have written like this. So H2O is going out from here. This compound will be formed. So option 1 is the correct answer. An organic compound A, C5H10O reacts with hydrogen to form hydrazone derivative B. The hydrazone B on being heated with KOH at about 180 degrees gives N-pentane. The compound A does not respond positively to Tollens reagent and to the iodoform test. The compound A is. So option 3 is the correct answer because if you take option 3, the condition given in the question is matching exactly. That's what option 3 is the correct answer. If you see clearly 3-pentanone. So whenever it is reacting with NH2, NH2, KOH at 180 degrees, it is showing that Wolff-Kishner reduction because in the question it is given no hydrogen, it is reacting with hydrogen, it is reacting with KOH at 180 degrees Celsius. Right? So that data indicates it undergoes Wolff-Kishner reduction. In the Wolff-Kishner reduction, C double bond O group will convert into CH2 group. Right? So this compound, why should we take this compound here? Why not other compounds, other options means? So here already given it does not respond to Tollens and Wheeling's reagent. So in this compound, it is a ketone group, right? So ketone group does not undergo positive test for Tollens and iodoform test also because there is no methyl ketone here. So it does not undergo for iodoform test also. So third compound we have taken as a correct answer. Option 3 is the correct. In the reaction CH3 twice CHNO2 plus HCHO in presence of a base, the major product is. So if you see here, so from here alpha hydrogen we are removing, from here carbonyl group we are breaking. So automatically this H plus will be attached on the O, H and this C plus will be attached on this carbon atom. So this compound will form like a aldol. how we do the aldol condensation, like that we applied here. In the following sequence of reactions, so ethanol reacts with phosphorus plus I2, like a red phosphorus plus I2. You take like that here. So what happens here if we react the alcohol with the red phosphorus plus I2, so OH will be replaced by the iodine. So now it is reacting with the magnesium in presence of ether. So Grignard reagent will be formed. This Grignard reagent reacts with formaldehyde. Then respective primary alcohols will be formed, no? Followed by hydrolysis according to the concept we have. Next, the compound A, this compound is given. It is on hydrolysis at 373 Kelvin. We are getting the compound B, right? So B reacts with hydroxyl amino but does not give tolerance test. Identify A and B. So answer is fourth option, because if we take the fourth option, then only we are getting the option product B also as a correct. So 2,2 dichlorobutane. First A I have taken like this, 2,2 dichlorobutane. So whenever it undergoes hydrolysis at 100 degrees Celsius, what happens here? Two chlorines will be replaced by two OH groups. On the same carbon atom, if two OH groups are present, automatically on heating, H2O will be going outside. So automatically here C double bond O will come. See, finally two butanone is coming now. So it does not give tolerance test they gave, no? It reacts with hydroxylamine. See, ketones will reacts with hydroxylamine, but it does not give tolerance test as a positive because it is a ketone. It is not a aldehyde. So everything is matched. No? If we take the fourth option as a correct, the data given is matching here. So fourth option is the correct answer. Also, so acetaldehyde can be converted into this compound by which reagent? So if we take the acetaldehyde, out of the following, which one if we take, then we will get this compound. It is the question. See here, formaldehyde we have taken here, and another mole of formaldehyde we have taken here, right? So answer is 3. Excess of HCHO and KOH we have taken. See here, one formaldehyde, second formaldehyde. Right? Sorry, acetaldehyde. The question it is given acetaldehyde. So 1 mole of acetaldehyde, 1 mole of formaldehyde. What we are applying here? So it is having alpha hydrogen, it is not having alpha hydrogen, right? So aldol condensation we are applying. So from here keto group, from here aldehyde group we are taking. So if we apply aldol condensation, we will get this compound. So again another molecule of the formaldehyde, second mole. Here first mole we use, no? Here second mole we are using because excess is given here. So again we are applying aldol condensation, we will get the compound in this manner. Again third mole of the formaldehyde we are taking, again we are applying aldol, so we will get the compound in this manner. Now in the fourth mole of formaldehyde, we are applying cancerous reaction. First step aldol, second step aldol, third step aldol. But in the fourth step cancerous, if we apply, we are getting the correct answer. Now in this question, A reacts with ozone, it is giving B and C, and B reacts with the dilute KOH, we will get aldol, this compound, and C reacts with concentrated KOH, benzyl alcohol and salt of benzoic acid is forming. And this aldol compound reacts with HCN, gives D undergoes heating and acidic hydrolysis. We are getting this compound. Then the number of carbon atoms in the structure A is, this is the question. So compound A is this one, because if we take this one as a compound A, the given condition in the question will be satisfied. So if we take this compound here, if we do ozonolysis here, O3ZnH2, it's a reductive ozonolysis. Then shortcut if we apply here, this bond will break both sides here, double bond O here, double bond O we should apply. So benzaldehyde will form here. So this is the compound C, right? This is the compound C, and another compound is this one, CH3CHO. This is the compound B. So that compound B, we are reacting with the dilute KOH, right? So it is aldol condensation because alpha hydrogens are present here. So aldol will form here. So this is compound, this aldol is formed. This aldol reacts with HCN, no, giving D. So reacts with HCN. This nucleophilic addition reaction takes place here. So double bond O will convert into respective cyanohydrin. That compound D on acidic hydrolysis, CN will be converted into COH. Again on heating, from the COOH OH group, from this carbon, from this OH group, hydrogen is eliminating. So here new bond will form, like a ring compound will form here. And then if you take the compound C, reacts with the concentrated KOH, it is indicating the Cannizzarose reaction. In Cannizzarose reaction, one molecule undergoes reduction and one molecule undergoes oxidation. Cannizzarose reaction is the example of a disproportionation reaction. Hope you understand. In this question, the total aldol condensation products including stereoisomers formed by the reaction between the acetaldehyde and acetophenone. See here, the total number of carboxylic acid groups in the product P they are asking. So acetaldehyde and two molecules are given, acetaldehyde and acetophenone. First acetaldehyde and acetaldehyde, two molecules of acetaldehyde, aldol we applied, then we are getting this compound. So this compound can show cis isomer and trans isomer. So here we can count two isomers. And acetophenone and acetophenone, aldol condensation, if we apply, we are getting this compound. It is also having cis and trans isomers. Now, one molecule of acetaldehyde, one molecule of acetophenone, aldol we applied. So we are getting this compound, cis and trans possible for this compound also. Now, same like above, acetaldehyde and acetophenone. But the difference between these two reactions is, in the third equation, in acetaldehyde carbonyl group we used, but in the fourth equation, acetophenone carbonyl group we are using. Right, that is the difference. So total 4 products are formed here. Every product can show geometrical isomerism cis and trans. So that's what total 4 into 2, 8 isomers will be formed. So answer is 8. The total number of carboxylic acid groups in the product P is, in this compound P, so how many carboxylic acids will be formed? That is the question. So how many COOH groups present in the product B? That is the question. So if we take the reactant, so if we react with acidic hydrolysis, then bond will break in this manner. Here hydrogen and here OH will be formed in this manner. So now H2O will be eliminated on heating. This compound will be formed. So some ring will be formed here. Then it is reacting with O3 and H2O2, indicating oxidative ozonolysis. So during the oxidative ozonolysis, what happens? This double bond will break. Then double bond CHO will form in the reductive ozonolysis, but it is oxidative. No? These two CHO groups will be converted into COOH and COOH. So total in the final product, how many COOH groups are present here? 2 are present. So answer is 2. Hope you understand. Thank you.